Hi, everybody. We're talking about the inverses of matrices in this screencast. Specifically, what I want you to learn is how to identify an identity matrix. I also want you to be able to find the inverse of a matrix. We're going to do it by hand, and I'm going to show you how to do it on your calculator. So have your calculator handy so that you can follow the steps with me. And then lastly, we're going to solve a system of equations using inverses. Okay, so let's get started. The first thing I want to do is I want to talk about this idea of the multiplicative identity. Take these three equations. If I take 6 and I multiply it by 1, I still have 6. 1/3 times 1 is 1/3, and a times 1 is a. So for real numbers, if I multiply a real number by 1, I'm not changing the value of that real number. For that reason, we say that the multiplicative identity is 1. Well, this idea of 1 with matrices is a little bit different, okay? So what we want to do is talk about the multiplicative identity for a matrix. So this idea of this matrix is if I take some matrix A and I multiply it by the identity matrix, either in A times I or I times A, I'm still going to end up with the same matrix. So this I is the identity matrix. Now, for a 2 by 2 matrix, so if A was a 2 by 2, the identity matrix associated with a 2 by 2 is this matrix right here, 1, 0, 0, 1. One's on the diagonal, zeros everywhere else. So let me show you how that works. So if I have some matrix A, which is 3, -1, -2, 4, and I multiply it by the identity matrix 1, 0, 0, 1, I end up with the same matrix, 3, -1, -2, 4. The same thing happens if I go in the other order. So if I take the identity matrix 1, 0, 0, 1, and I multiply it by A, I still have A. Okay? Now, I is called the identity matrix. What we just looked at was an example of what it looks like with a 2 by 2. But depending on how big A is will determine what your identity matrix looks like. So for example, this first one right here, this is what the identity matrix looks like for a 2 by 2. We saw that in the previous screen. But here's the identity matrix for a 3 by 3. And here's the identity matrix for a 4 by 4. If we had an identity matrix here for a 5 by 5, there would be ones on the diagonal and zeros everywhere else. Okay, so let's look at this. So we talked about this idea of a multiplicative identity, which with real numbers is that number 1. But now I want you to shift your focus to a multiplicative inverse. So for example, the multiplicative inverse of 6 is 1/6 because 6 times 1/6 gives me the multiplicative identity 1. What would be the inverse of 1/3 then? What number multiplied by 1/3 is going to give me 1? Well, that answer is 3. 1/3 times 3 is equal to 1. Are you catching on that you're multiplying by the reciprocal? And how do we write the reciprocal of a real number? Well, the way we write that is with this inverse. So A times A inverse is equal to 1. So for real numbers, the multiplicative inverse is always the reciprocal. And A times its inverse is always equal to 1. If you understand this screen, this is going to help you when we apply this idea to matrices. So now we're going to have some matrix A and its inverse, which is called A inverse. That's how you pronounce this. You don't say A to the -1. Use the language. It's A inverse. So A times A inverse is going to give me the identity matrix I, and A inverse times A is going to give me the identity matrix I. Now, a couple things. Only square matrices can have an inverse. Did you notice when we were going through those inverses, we were talking about all matrices that had the same number of rows by the same number of columns. Remember, we had a 2 by 2, a 3 by 3, a 4 by 4, and I mentioned a 5 by 5. It's only square matrices that can have an inverse, but not every square matrix has an inverse. These are really important concepts to understand. Okay, so what we want to do is we want to talk about how do we find the inverse of a matrix. So we have this matrix A, which we're going to call -2, 3, -3, 4. We're going to define it that way. And we want to find the inverse of the matrix. Here's an overview of what we're going to do. And on the next screen, you'll see how I have it worked out. So the first thing we're going to do is make an augmented matrix. But we're going to augment the 2 by 2 matrix with its 2 by 2 inverse identity matrix. The identity matrix. So 2 by 2, 2 by 2 identity, A and I. Now what we have to do is we have to put this into reduced row echelon form. And so that means basically we're going to end up with the identity matrix on the left, and we're going to have the inverse of A on the right. So when we're all done, it's going to look like this. So in row echelon form, where we have ones on the diagonal and zeros everywhere else, here you're not going to end up with 1, 0, 0, 1. What you're going to end up with are the elements that form the inverse of A. Here's what it looks like. So we started with A, augmented with the identity matrix, and then you go through this series of steps to put it into row echelon form, dividing everything by -2, and then we're going to add these so that we end up with a 0, multiply by 3, add them together, etc. And I know it's complicated fractions in here. Nobody likes fractions. But when you're all done and you have the identity matrix on the left, this matrix on the right is our inverse. Okay, so let's look at it on our calculator. So this could be cumbersome, really easy on your calculator, watch. So first thing we're going to do is edit matrix A, and I already did that. So that matrix is in there. If you don't have it in your calculator, put it in there now. And then I'm going to quit, and I'm going to call the matrix up. So matrix A, I'm going to name that matrix, and then I'm going to press the inverse button. That step is extremely important. If you use the caret button and the -1 exponent, sometimes it'll work, but sometimes it won't. So this key on your calculator means inverse. Make sure you're training yourself to always use this button when you need the inverse. So A inverse, press enter, and there you have it. Look how easy that was. Plug the matrix in your calculator, raise it to the or press the inverse button, and there it is. It pops up. Okay, so let's look at another example. Remember I told you that not all matrices have inverses. So here's an example of a matrix that doesn't have an inverse. And when you go to find the inverse, you're going to get this error message that says that it is a singular matrix. So watch how this happens. If I type this matrix, matrix A, and I already did that here in the calculator. So if I put this 3 by 3 matrix into my calculator, and I go to find the inverse of the matrix, you've got to teach yourself to look and pay attention to what the error messages say. It's not just that there's an error, but the error says that there is a singular matrix. So that's telling you you didn't do anything wrong. It's just that this matrix doesn't have an inverse. Okay, now, how are we going to use this information? So I want you to take you back to a previous screen that we had. It was in the last screencast, the one that had to do with matrix operations. So at the very end of that screencast, what we started to do was we wanted to take a system of equations and write it using a matrix equation. So we formed the coefficient matrix, which we called A, the variable matrix, which we called X, and the constant matrix, which we called B. And A times X is equal to B. If you missed that screencast, go back and watch it, because I'm using that concept here. All right, so here we have the equation A times X equals B, which takes us back to the original system of equations. Well, remember that A inverse times A is equal to the identity matrix I. Now, using the basic concepts of algebra, I'm going to multiply both sides of this equation by A inverse. So A inverse times AX and A inverse times B. So if I multiply these on that A inverse on both sides. And I have to show you, you got to do it in the right order. So notice I did A inverse times A, so I have to do A inverse times B. The multiplication with matrices is not commutative, so you have to pay attention to what order you're doing it in. On this side, the order wouldn't matter because you'd end up with the same number. But on this side, it does. So we're taking A inverse times B. And the result is going to be the identity matrix times X is equal to A inverse times B, which just means X is equal to A inverse times B, which is awesome. So let's do that on our calculator. So you're going to have to edit the matrices. So edit matrix A. And you'll notice I already did that. So I have the 3 by 3 matrix in there, 4, 2, -1, 9, 0, 1, 4, 5, and -2. And then we're going to edit matrix B. And matrix B is a 3 by 1. And the elements of that matrix are 3, 5, and 1. So then we're going to type this exactly like this in our calculator. And we'll have our calculator do all the work for us. So second matrix, call up matrix A inverse times matrix B. And check to make sure you have it right. A inverse times B, press enter. And this is what it looks like in decimal notation. Now remember, you can always press math and change everything to a fraction. And there's what it looks like in fraction notation. So here are the answers. So the solution is X is 6/7, Y is -11/7, and Z is -19/7. So this is another way to do it. All right, now what I want to show you is when this method is not going to be very useful. So for example, I went a little too fast. Here's a new system, okay? So just like before, you're going to edit those matrices. So I'll just show you that I put those matrices in my calculator. So I have the new 3 by 3 matrix associated with this system. That's the coefficient matrix. And I have the new constant matrix, and that's the 3 by 1 matrix, which we call matrix B, which is 9, -15, and 2. And once you have those in your calculator, you're going to pull them up again, matrix A and A inverse, and then matrix B, and press enter. And notice we get that singular matrix solution again, or error message, whatever you want to call it. Now here's the thing. When that happens in this situation, that just tells you you're not going to get a nice, pretty answer. So that means the answer to this system is either no solution or all real numbers, and you'd have to come up with the system, okay, with the formula for those. And there's no way to do this with inverses. So what you have to do if you want to find that answer to find out if there's no solution or if there is an infinite number of solutions, is you're going to have to do that reduced row echelon form. So instead of it being a 3 by 3, it's got to be a 3 by 4. And then we have to put that last column in, which was 9, negative 15, and 2. And then we're going to do the RREF. So we're going to use the math, toggle up to RREF. We're going to do this to our new matrix A. This is the 3 by 4 matrix A. And notice we get that row on the bottom that has zeros and then a 1. And remember, when that happens, there's no solution. All right, that's it. Lots going on in this screencast. So email me if you have any questions.